Permutation and combination, exercise number 1 from the worksheet. Question number 1. We are solving the first sub question. 3 into 6 into 9 into 12 into 15 into 18. 3 is 3 into 1. 6 is 3 into 2. 9 is 3 into 3. 12 is 3 into 4. 15 is 3 into 5. And 18 is 3 into 6. Okay. Now all these terms are in multiplication. Okay, there is multiplication, sorry. Okay. So look at the first term. It's 3 everywhere. So 3 is occurring 6 times. So this is 3 raised to 6. 6 into 5 into 4 into 3 into 2 into 1. That is 6 factorial. So that is the first answer. Okay. Second one. 6 into 7 into 8 into 9, 10, 11, 12. Now we have to express in factorials. So I'll just reverse this. Now to make this 12 factorial, we have to complete the series. So multiply and divide by 5, 4, 3, 2, 1. So I multiplied by 5, 4, 3, 2, 1. I divided by 5, 4, 3, 2, 1. So this is equal to 12 factorial upon 5 factorial. This was question number 1. Let's go to question number 2. So question 1. N plus 1 factorial equal to 20 into n minus 1 factorial. See, this notation is factorial notation itself. Okay. So n plus 1 factorial upon n minus 1 factorial is equal to 20. The bigger term over here is n plus 1. How to identify? By putting a sample value of n. Let's put n as 10. So 10 plus 1 will be 11 in the numerator and 10 minus 1 will be 9 in the denominator. Okay, so n plus 1 definitely is the bigger term. Okay, now n factorial is n, n minus 1, n minus 2, dot, dot, dot. Okay, this we have already done in class. Right? So the first term of n factorial is n. We have taken a decision to reduce this bigger factorial. So the first term of n plus 1 factorial will be n plus 1. The previous term will be n plus 1 minus 1. Okay, I cannot stop over here because I'm not getting n minus 1. So let's not put a factorial over there. N plus 1 minus 2 factorial upon n minus 1 factorial. I stopped over here because I got my n minus 1. So I stopped over here, n minus 1 factorial. Okay. So n plus 1 into n. Okay. Because plus 1 minus 1 is gone. This is n minus 1. So this is n minus 1 factorial upon n minus 1 factorial is equal to 20. Okay. So n minus 1 factorial, n minus 1 factorial is gone. Now n plus 1 into n are two consecutive terms. If you want to test, put the value of n as 10. So 10 plus 1 is 11, 11 into 10. Okay. So right hand side also we will divide this 20 into, we'll split this into two parts such that there are two consecutive terms. So I cannot write 10 into 2 because 10 and 2 are not consecutive. So I'll just write 5 into 4. Okay, so two consecutive terms is equal to two consecutive terms. So either now you equate the bigger to bigger or smaller to smaller. So I'm equating bigger to bigger, n equal to 4. Okay, and if you want to equate smaller to smaller, you'll get the value of n as 4. Smaller term equal to smaller term. Do anyone. Okay, next one. Sub question 2. 1 upon 5 factorial, 1 upon 6 factorial, n upon 6 factorial. Okay, we need to find the value of n. So 1 upon 5 factorial, 1 upon 6 into 5 factorial, n upon 6 into 5 factorial. We are reducing 6 factorial, this both 6 factorial to 5 factorial. Okay, yeah. So here the common term is 1 upon 5 factorial. So 1 plus 1 upon 6. N 6 into 5 factorial. Okay. So after taking common 5 factorial is gone. 1 plus 1 upon 6 is 7 upon 6. So cancel out 6, n is equal to 7. Third sub question. Third sub question. 1 upon 6 factorial plus 1 upon 7 factorial, n upon 8 factorial. So we'll convert everything to the smallest one, that is 6 factorial. 7 into 6 factorial. 8 into 7 into 6 factorial. So 1 upon 6 factorial is common. 1 plus 1 upon 7. Okay. So I took 6 factorial common and now I can cancel it. So this is going to be 8 upon 7. So 7 and 7 is 1. N is equal to 64. N is equal to 64. Next one. Fourth. N factorial. N minus 2 factorial is equal to 110. N, N minus 1. N minus 2 factorial. N minus 2 factorial is equal to 110. Okay, by the way, I reduced n because out of n and n minus 2, n is the bigger term. So I reduced n till n minus 2 and I stopped at n minus 2 because down it is n minus 2. Now these are two consecutive terms. So right hand side also I'll make two consecutive terms. Okay, bigger to bigger or smaller to smaller. We'll get the answer. Sub question 5. N factorial 2 into n minus 2 factorial divided by n factorial 4 into n minus 4 factorial equal to 1 is to 6. Okay, n factorial into 4 into n minus 4 factorial upon n factorial is equal to 1 upon 6. This and this is gone. Out of n minus 2 and n minus 4, n minus 2 is the bigger term. Okay, and this 4 upon 2 is equal to 2. So we'll reduce n minus 2 factorial. Why n minus 2 is the bigger one? Because if you put the value of n as 10, n minus 2 is 8 and 10 minus 4 is 6. So bigger obviously is n minus 2. So the first term of n minus 2 factorial is n minus 2. The previous term is n minus 2 minus 1. Previous term is n minus 2 minus 2. I'll stop over here because I got my n minus 4 factorial is equal to 1 by 6. Okay. So this term and this term will get cancelled because both are n minus 4 factorial. This is going to be n minus 3. So 2 into 6, that will be 12, equal to n minus 2 into n minus 3. Now these are two consecutive terms. So 12 I'll break down into two consecutive terms. I cannot write 6 into 2. They won't be consecutive. Okay. So equate bigger to bigger or smaller to smaller. Bigger term is n minus 2 and over here it is 4. So n minus 2 is equal to 4. Therefore n is equal to 6. That was your question number 2, sub question 5. Okay. 3, sub question 1. In a cricket match, how many choices can be made for man of the match? Okay. Now there are two teams, A and B. 11 players are there in team 1, 11 players are there in team 2. Okay. So there are total 22 players who are playing the match. So man of the match can be awarded to any one of these 22 players. Okay. So the total choices are 22. Second one, in a class there are 22 girls and boys there are 17. 22 girls and 17 boys. The teacher wants to select either a girl or a boy to represent the class in a function. Girl or a boy. Okay. Or is addition. In how many ways that this teacher can make the selection? So there are in total 39 kids. Okay. So out of this 39, one has to represent the class. So there are 39 choices. Okay. For sub question 1. In a class there are so for sub question 2. 1 second. Yeah. For sub question 1. There are 17 girls and 22 boys. One girl. We need to form a team. It's not term. Huh? It's team. Team of one girl and one boy amongst the students of the class. Okay. So there should be one girl and there should be one boy out of 17, out of 22. Okay. Respectively. So one girl out of 17 can be selected in 17 ways and one boy can be selected in 22 ways. So as I said and because this time we don't require a representative from the total. We require a representative from both the categories. So girls and boys. So there are 17 choices in girls, 22 choices in boys, and 7 and 22 choices in boys. So we are going to multiply this. We'll get the answer. 4 sub question 2. 11 players are there in a cricket team. One has to be chosen as captain, and the other has to be chosen as vice captain. Captain can be selected in 11 ways. Okay. Now vice captain. After one person is selected from 11 as a captain, there are only 10 players left. So vice captain can be selected in 10 ways. So we are choosing a captain and a vice captain. So we are going to multiply this. Okay. Third one. Lata wants to go abroad by air and return by ship. She has a choice of 6 different airlines to go. Okay. So from A to B, there are 6 different choices, 6 different airlines. And from B to A, back, return journey. There are 4 different ships. In how many ways she can perform the journey? So from A to B, she can travel in 6 ways, and from B to A, she can travel in 4 ways. So 6 into 4, that is equal to 24. By sub question 1, there are 4 doors in a lotus temple. In how many ways can a person enter the temple and leave by a different door? So entering, there are 4 choices, 4 ways. We can select any one way. And while making an exit, okay, one door is not allowed for him now because he cannot come by the same door. He has to leave by a different door. Okay. So for example, door number 1, 2, 3, 4. So while entering, there are 4 choices. Suppose he's entering by door number 3. So while returning back, he cannot come by door number 3. So for while returning, there are 3 choices left. So 3 ways. And is multiplication. So 4 into 3 is 12. Okay. 5 sub question 2. 4 persons ABCDI to give lectures to an audience. In how many ways can the organizer arrange the order of their representation? Okay. Now lecture 1 and lecture 2. Okay. Lecture 1 can be given in how many ways? 4 ways. There are 4 choices. Lecture 2 can be delivered in 3 ways. Why 3 ways? Because, for example, if person C is giving lecture number 1, he cannot be counted over here. So who will be counted over here? Here only A, B, and D can be counted, out of which anyone will give the lecture. So there are 3 ways. Okay. So 4 into 3, which is equal to 12. Question number 6, sub question 1. Find the number of 4-lettered word with or without meaning which can be formed out of the letters of the word rose. Okay. So the objects with me are R, O, S, E. We need to form a 4-lettered word. 1, 2, 3, and 4. So the first box can be filled up in 4 ways. R, O, S, and E. 4 ways. Repetition is not allowed. So the second box will be filled up in 3 ways. This will be in 2 ways and this will be in 1 ways. Okay. So the final answer is 4, 3, 2, 1. We have to multiply all this because we are filling up the first place, second place, third place, and fourth place. Okay. Right. And if repetition is allowed, then all 4 boxes will be 4. So that will be 4 raised to 4. 6 sub question 2. Okay. So the objects are M, O, T, H, E, R. Okay. And the words will begin with T. So T, this particular place and this particular object is fixed. Whatever arrangement is there, we have to do it over here after T. So we'll not count T, okay? So now T is gone. So how many letters are left? There are 4 letters left. So there will be 4 spaces. Sorry, 5 letters left, 5 spaces. 1, 2, 3, 4, and 5. Okay. So this can be filled up in 5 ways. Why 5 ways? M, O, H, E, R. This will be filled up in 4 ways. This will be in 3 ways. This will be 2 ways, and this will be 1 way. Okay. So 5, 4, 3, 2, 1. Okay. Otherwise, this is 120. Okay. 5 factorial. Otherwise, from here to here, Number of places are 5, number of objects are 5. So NPR 5P5, which is equal to 5 factorial. This also we have discussed in class. Permutation is arrangement without repetition. Okay. Question number 6, sub question 3. For a group photograph, 3 boys and 2 girls stand in a line in all possible ways. Okay. In how many ways could a photograph be taken? How many photos could be taken if each photo corresponds to? So there are 3 boys, B1, B2, B3, and 2 girls, and they are standing in a line. 1, 2, 3, 4, 5. Okay. Now first place will be filled up in 5 ways because there are 5 objects. There, there is no specific order that girls will be together, boys will be together, nothing like that. So we have to consider all objects at once. Second place will be filled up in 4 ways because if G2 sits over here, we cannot count G2 for the next place. So there are 4 options left. And since there is no repetition, you cannot repeat this people. Okay, it's but obvious. So one place will have one less object. So this is equal to 5 into 4 into 3 into 2 into 1, which is equal to 120 ways. 6. Sub question 4. Okay. 6 pictures are to be arranged in a line from left to right. So left to right, 6 pictures. 1, 2, 3, 4, 5, 6. Okay. How many arrangements are possible? So there are 6 pictures. Obviously, there will be 6 places. Okay. So first place can be occupied in 6 ways. Second, 5 ways. Because at the first place, you can select any one of these 6 pictures and put it over there. So there are 6 choices. 6, 5, 4, 3, 2, and 1. So the total is 6 factorial ways. One more way of solving n is equal to 6 pictures, r is equal to 6 places, npr 6p6, 6 factorial ways. Okay. Question number 7. Sandy has 5 shirts, 4 pants, 3 pairs of socks, and 2 pairs of shoes. In how many ways he can dress himself? So a shirt can be selected in or can be chosen in 5 ways because there are 5 shirts. So there are 5 choices. I'll say and. Okay. Pant will be selected in 4 ways and socks will be selected in 3 ways and shoes will be selected in 2 ways. Okay. So total number of ways in which he can dress himself is multiply all this. He's going to select a shirt and a pant and a socks, pair of socks and a pair of shoes. So this many number of ways. I'm saying and so it's multiplication. Okay. Question number 8. How many lettered code words are possible using the first 10 letters of English alphabet? If no letter is repeated, letters can be repeated. Okay. We are forming a 3-lettered code word. Objects are A, B, C, D, E, F, G, H, I, N, G. Okay. So first part is repetition is not allowed. So the first box will be filled up with Okay, 10 ways because there are 10 options. Second will be 9 and third one will be 8. And so this, since this is permutation without arrangement, you can also use NPR formula. Okay, so this will be 10p 3. Why 3? Because there are 3 places and 10 objects. So both will give you the same solution. Second part, repetition is allowed. You cannot use the formula NPR formula over here. Don't do that. Okay. So here 10 objects can be 10 choices can be made in the first place, 10 in the second because here we can repeat the letter and 10 over here. So the second answer will be 10 into 10 into 10. The first is 10 into 9 into 8 or 10p3. Okay. And this is 10 into 10 into 10. Okay. Question number 9. So question 1. The coin is tossed 2 times. So toss 1 can give you heads and tails, 2 outcomes, and toss 2 heads and tails, 2 outcomes. So the total number of outcomes are 2 into 2, which is equal to 4. Why into? Because we are multiplying. If it is tossed 3 times, okay, so I'll write and third toss. There are 2 outcomes which are quite possible. Okay, 2. So the total number of outcomes will be 2 into 2 into 2, which is equal to 8. Okay, if there are 4 times, then again toss 4 I will write. Again 2 will be written over there. So 2 into 2 into 2 into 2, 4 times. 2 raised to 4, 16. And when it is 5 times, it is 2 raised to 5, which is equal to 32. Okay. Question number 10. There are 6 flags of different colors. How many different signals can be generated by hoisting a flag on a vertical pole, one above the other, if each signal requires the use of 2 flags, 3 flags, and 4 flags? Okay. So first is we are creating a signal, flag 1, flag 2, and flag 2. Okay. Now flag 1 can be selected in 6 ways because there are 6 different colors of flags. Any one will be placed over here. Flag 2 will be selected in 5 ways because one is utilized in the first flag as a first flag. So there are only 5 flags left, which can be utilized over here. So for the first, the answer is 30 ways. Okay, you can create a signal. For second one, there is flag 3 as well, and flag 3. So the third flag can be selected in 4 ways. Okay, because now there are only 4 flags left, which can be kept over here in the third place. So 4 over here, 6 into 5 into 4. Okay, and 4 flags again, flag number 4 can be selected in 3 ways. So 6, 5, 4, 3. You have to multiply all this. That is the end of exercise number 1.